Hello and welcome to Channels, the Nextflow podcast. My name is Geraldine, and I'm joined today by Ben Sherman, software engineer at Secure Labs. Hi, Ben.
Hey, guys. Nice to be back.
Yeah, it's been a while since you've been on here, I think.
Yeah, it has.
Well, welcome back. And today we're going to be talking about GA4GH interoperability standards. So, for those of you who don't know GA4GH, it spells out to Global Alliance for Genomics and Health. It's an organization, a nonprofit organization that's primarily volunteer-based that aims to develop standards for infrastructure, legal frameworks, policy and ethics in primarily human genomics, where it applies to health, precision medicine, and all of that. And so it's an international effort, and the goal is to have global standards where everybody can agree on how infrastructure platforms should talk to each other, the kind of formats that we should use, but also frameworks for, like, for example, what's the right way to get consent from patients for their data to be used for research, trials, etc. And so it's kind of, I think of it as a little bit the UN for human genomics. The goal is really to have participation across the globe from as many countries as possible, so that it's not just the usual countries leading the charge, but that everybody gets to participate in deciding how genomics will be used, applied to further human health and medicine going forward. Now, we are specifically going to talk today about certain interoperability standards from a technical standpoint, specifically how that affects, hopefully for the better, the Nextflow community and people who run Nextflow pipelines. A little bit of background: the GA4GH as an organization is organized in work streams. So there's work streams on particular topics. I'll caveat that I co-lead the large-scale genomics workstream, so I'm a bit of a cheerleader for GA4GH in general. Large-scale genomics workstream in particular is a group that focuses primarily on file formats and kind of data retrieval protocols. Think, for example, CRAM, VCF, RefGet, which is a standard for retrieving reference sequences from platforms that support it. Anyway, so that's kind of more on the file formats, data formats side of things. But today we're going to talk about how about certain standards that apply to tools and data retrieval from a point of view of pipelines. So we're going to talk about the four main standards that are applicable in this context, which are TES, WES, TRS, and DRS. I'll spell that out for you. TES, or TES, is the tool execution schema. Ben, interrupt me if I get any of these wrong. WES. Hey, say again.
It's task.
Oh, task. You're right. It is task, not tool.
Service. I can never remember exactly which, but yeah.
I tend to mix them up. WES is the workflow execution schema. TRS, TRS, is for task. Oh gosh, I've forgotten. What does
That's
this
the tool?
Yeah, that's the tool one. Yeah. See, it's a bit of an alphabet soup. And then there's DRS, which is the data retrieval service. So obviously, these can be confusing. There's a lot of acronyms thrown around, and we pronounce things in a way that's not necessarily obvious. So part of what we're going to try to do today is raise awareness a little bit, disambiguate what these things are, and why Nextflow users should care about them.
Yeah, these standards are pretty interesting to me. You know, anytime I encounter standards like these, I always think of that XKCD's comic where somebody complains about there being like 14 file formats and they create a 15th, whatever it is. I tend to be pretty skeptical of these like attempts to standardize over everything. But what I like about these GA4GH standards is that they seem to be oriented around like a very particular problem set, right? Like they're not trying to solve all the world's problems. They seem to be focused on genomics and sort of the biggest problems that exist around those. And so at this point, there's the integration with Nextflow is very spotty, and we'll get into that. But honestly, I'm interested, like you said, to raise awareness about these standards, but also even to maybe encourage more collaboration between the Nextflow community and the people who work on these standards. I'm involved a little bit, but I can only do so much. But if there's people who are interested in using these standards or use Nextflow, who are interested in coming at it from either end, trying to help, strengthen those connections, this is a huge area where the community could get involved and help do that.
That's a really great point. And I would say, like, for example, a lot of people listening probably know what a VCF file is, variant call formats. Everybody has at some point complained about how terrible format VCF is. Either it's not machine readable enough or it's not human readable enough. There's a lot of issues around it. There's an effort right now ongoing that's trying to determine what is the future of VCF. If you think about all the kind of the shortcomings of the current formats, trying to develop like what's going to be the next iteration of that. Is it an incremental update where we enable VCF to handle a little bit more things, like can we make it handle pangenome references or something like that? Or do we actually go to something completely new that's going to be better at handling kind of the next wave of research that's heading our way in human genomics? If we think about the scale of cohorts, think about a cohort of 1 million people. You can't represent 1 million people's variant calls in one VCF file. You already struggle at much lower numbers. So these are the kinds of problems that need to be solved before it becomes a problem for everyone. Because admittedly, right now, there's not a lot of groups in the world who have 1 million samples that they need to handle together. But this is something that's coming towards us kind of inexorably. And part of what GA4GH is trying to do is try to solve some of those problems before they become crises. And so I see that kind of with the cloud workstream that works on some of these other standards that we mentioned. It's not applicable to everyone yet, but we need to start thinking about how do various computing platforms, data platforms interact, so that if you're working on a platform and you need to access data that's in a registry that's hosted on a different platform, how can you do that without having to download and re-upload just terabytes of data? How can you set up, execution of tools and pipelines in a way that you can have them set up and configured in one place and just run them anywhere without having to lose your mind over configuring them again differently on some other platform? Like, how can we make all of that kind of work much more streamlined, particularly with the viewpoint of enabling researchers who should be focusing on their actual research and not on figuring out how to access data or how to run tools and stuff like that, because that really shouldn't be their job. So that's the pitch. Really, is how do we figure out how to set those things up?
Well, that sounds pretty good to me. Pretty good pitch.
Thank you. Let's hope everybody feels motivated to kind of, join the effort, because it is the kind of thing you can sit in a corner and let somebody else decide what the future is going to look like, or you can step up and get involved. And there's a lot of calls for participation of like, help us think through it. Whether you're a software engineer and you want to help design and build the code, or you're a researcher and you're like, I can explain exactly what my use case is, and this is what I need it to do, so that the people actually building the tools are going to build something that actually solves your use case, as opposed to something that was, miscommunicated through a game of telephone. So
Yeah, absolutely.
So let's get into the standards. Bryn, do you want to tell us about TESS?
Yeah, so we'll start with TESS, the Task Execution Service, because this is the one that's probably the most supported in Nextflow. It's really the only one that's supported at all, so that's why we start with it. But so yeah, from TESS is basically an API which defines basically an API that defines some kind of service that can execute tasks. I didn't want to say it that way because it's in the name, but that's what it does. I mean, these names are pretty descriptive. From Nextflow's point of view, TESS is essentially another executor. So just like Nextflow, can submit jobs to Slurm or AWS Batch or your local machine or Kubernetes or whatever, it can submit jobs to a TESS endpoint. And the important thing to understand is that it's a standard or a API specification, right? So there's a difference between the TESS standard and then implementations of TESS. So there are many different implementations of TESS. The most widely known one, I think, is called Funnel, which is meant to be sort of a reference implementation. You can deploy Funnel, on your laptop for testing. You can also deploy it on top of an HPC scheduler. I think you can even deploy it on the cloud as well. And it's pretty standard TESS implementation. And then there's another prominent one is Azure. So Azure has like a TESS backend. And then likewise, there are many, you could say, TESS clients, I guess, basically workflow managers that can integrate, that can submit jobs to TESS. So Nextflow is one, but then CWL, Whittle, SnakeMake, all the major bioinformatics workflow managers support it as well. Interestingly, Nextflow proved to be the most difficult one for the TESS developers to support, I guess, because there are certain patterns in Nextflow that are possible, which are not possible in other workflow managers. In particular, there's things around having globbed outputs process that can emit, a glob of arbitrary set of files based on a glob pattern. Was not supported in TESS for a long time. Also something around output directories. So for this reason, TESS has been supported in Nextflow for a very long time, but it's had a very limited use because, there are all these sort of implementation gaps. And over time, the TESS standard was updated. They actually tried to cater to us, and they found ways to fill those gaps. But these things take time. It's sort of it's open source community effort. So the API spec has been updated, and then now there's a PR in Nextflow to sort of update the Nextflow side of things to use that updated API and then close all those gaps so that the TESS executor in Nextflow is sort of like a first class executor that is just as functional as all of the others. That's basically where things are with TESS now.
That is very helpful. That is very helpful. And do you foresee having support for TESS in Sakara platform as well? Do you know if that's on the roadmap?
I don't think it's on the near-term roadmap, but if the current efforts with Nextflow were completed, it certainly wouldn't be very hard to say, just add another to be able to have TESS as a basically a compute environment in Sakara platform, and that would be very flexible because again, that's the TESS compute environment isn't necessarily tying you to a particular cloud platform. It's whatever implementation you want to use. So you have to set up the back end yourself, or you have to be part of an organization that has it set up. But then once you use it, it's the same interface everywhere. So we'll have to see. It might take some time before that happens. One thing I will say, though, about that I find promising about TESS is that one of the sort of design trade-offs that Nextflow makes, a lot of workflow managers require you to deploy a database in order to sort of coordinate everything, maintain all the task metadata and stuff like that. Nextflow doesn't do this, which makes it a lot easier to set up. It's basically a CLI tool. You can just run it anywhere, right? There's not really a lot of setup. But the trade-off is that it uses the file system as the database. So, there's no free lunch here. And so the downside of that is that when you're running large pipelines with Nextflow, the file system can become a bottleneck because Nextflow is just writing so many of these little files and transferring files back and forth all the time. And so you have to have a really high performance file system in order to be able to run Nextflow at scale. But one thing that a lot of test implementations do is that they basically manage all of that metadata in a database. And so this could allow you to run Nextflow pipelines basically to take the other end of that trade-off, to say, you know what, I'd rather use a high performance database and not get bogged down by the file systems. Maybe I'm on a HPC cluster and my sysadmin is getting on to me about, overloading our shared file system, right? So maybe what we do is we set up a test endpoint on our cluster and we set up the database for that. And then Nextflow can just sort of transparently use that because it can just submit jobs to tests, and tests can manage all the metadata. Nextflow doesn't have to create all these sort of little helper files that clog up the file system. And that can be a nice trade-off without having to do a lot of refactoring in Nextflow, right? Because we could just change Nextflow to use a database directly, but that would require a huge amount of changes, right? But allowing that to be handled sort of at the executor layer is a really elegant way to sort of provide those different design trade-offs to users. So I'm very interested in that sort of prospect. We'll have to see how some of these test backends develop.
That's fair. Yeah, I would expect that would be popular. I've heard that kind of cited as one of the sticking points for some folks in some institutions. So if you can fix that for us, Ben, that would be fantastic.
I'll get right on.
All right. All right. Well, Tessa's little brother, little sister, I'm not sure. Wes, workflow execution schema. How is that different from Task?
I guess I feel like Wes is probably the bigger brother or sister because it's sort of at the next layer of abstraction, right? So it's sort of the same idea, except instead of submitting tasks, it's submitting workflows. So it's a bit more vague, I guess, in terms of how well defined it is. And instead of when you submit a job test, you basically provide all this information like the task script, input files, all that stuff. I haven't actually used Wes myself, so I'm not going to be able to speak in as precise terms about it. But my understanding is that you basically submit an entire workflow to it, and you specify the workflow manager you want to use, and I guess you can give it like a Git repository of like the pipeline you want to run, and then I guess you have to tell it how to actually launch the pipeline, and it's kind of the same sort of setup as test, where you have the Wes API, and then you have Wes implementations, and then you have you can have a client that can use Wes. And so in this case, Sakura Platform is actually an example of a Wes implementation because Sakura, the platform exposes the Wes API as part of its overall API. And there are some customers who use that to submit their workflow runs through the Wes API instead of through the standard interface of like launching a pipeline in the UI and things like that. And is that
what Sakura Kit uses under the hood for submitting for using the platform through the API, or is that a separate thing?
Well, Sakura Kit uses the CLI and the API under the hood, but I don't think it uses the Wes piece of that specifically. The Wes API is sort of an alternative method that you can use.
Interesting. Cool. Yeah, I think that's a very helpful. I think it's a very helpful distinction, like the task level execution and platform as the WES implementation. Honestly, I understand it better now that you've told me that. That's pretty cool. Okay, so then, sorry, was there anything else you wanted to say about WES? Because otherwise, it moves straight on to TERS.
I mean, not really. As far as I know, we support it in the platform, and there's not much more to say about it.
That's good. Support is good. Okay, then let's move on to our third of 4 standards, TRS, TRS for tool registry schema.
I think it is the tool repository service, or maybe it's the tool registry service. I feel like both names could be valid.
We'll put the exact name in the description.
This is like a running game now of guess the exact wording.
Yeah.
But you get the idea of whether it's repository or registry. I mean, the idea is so the TRS and DRS, I think they operate a bit differently in terms of they're a little bit different structure than TES and WES. So I think TRS is meant to be sort of like a URI standard. Like you can kind of think of how like S3 is like a special kind of URI that provides access to a certain kind of storage, right? And you can use Amazon's S3, or you can spin up your own S3 endpoint, basically. And as long as you follow the S3 protocol, then users can access your data just the same way as they would on AWS, right? And I think this is kind of the same idea where the TRS ID is sort of the standard format that can be used to access some kind of tool. And I believe this could be, an individual, like a command line tool or wrapper or module, or it could be an entire workflow. I think in practice it tends to refer to an entire workflow. But the TRS ID is sort of this universal URL that allows you to uniformly access, the tools using a standard specification across potentially many different providers. So again, you could have many different websites which basically expose their tools or workflows with TRS IDs. Then from a user point of view, you could access all those different ones, through sort of the same mechanism.
And I believe that's what DocStore uses under the hood, right?
Yes, DocStore, I think, is the primary example that I know of, is that it's basically like a registry for workflows. And then also every workflow has a TRS ID associated with it.
Yeah, so that makes it possible. Like I'm most familiar with DocStore as a developer and consumer of workflows from my previous life when I was working with Whittle and not Nextflow. But it supports Nextflow as well. So there's Whittle, CWL, Nextflow, and I think it supports Galaxy workflows now as well. And what's neat is that, so this is for people who are not familiar with DocStore, so docstore.org. It acts as a repository of workflows. There's a whole list. You can search, by language, by use case, by group that develops. There's a lot of options, and you can select a workflow of interest and then export it to your compute platform of choice. And so it's because it's been developed in part as part of some NIH funded projects. There's some connections with some of the cloud platforms that are NIH funded. And it is also supported by secure platforms. So there is a way that you can select your workflow and be like, okay, export to secure platform. Although I think the button still says Tower. But it
might be out of date.
So we've got to work with them to get that updated. But basically, you hit that, and then you have a process that's fairly streamlined. So you don't have to download the pipeline code and then re-upload it to platform. You can just import it straight away, and that just cuts down the number of steps that you have to take in order to use a workflow that you find in one of these repositories, which I think is really cool.
It is quite nice. It wasn't something I thought about for a long time because, I was just so used to working with GitHub repositories, for instance, that the Kara platform, the standard approach is to go and create a pipeline in the platform and put in your GitHub URL. And to me, I was like, well, that's pretty straightforward. But and that makes sense if you're like a pipeline developer and you're used to using all those tools. But over time, I came to understand how, if you're like a scientist, but you don't develop pipelines, you just sort of use them, then actually this is really useful because you might not spend a lot of time on GitHub. But Doc4, these registries are probably a nice way to sort of discover pipelines. You're mainly concerned with, like, does it do the thing that I want it to do?
Yeah.
Then you don't really need to worry so much about GitHub URLs. You just click a button and then you're ready to go. It's very powerful.
Yeah, and I mean, it is still backed by GitHub in the sense that
Right.
you don't have to, but if you have your pipeline in GitHub as a workflow developer, you can set it up in Doc4. It's a couple of clicks. You basically point to your GitHub repository and say, like, this is the main. You can have imports. It supports quite a lot. And then, yeah, people who are just browsing for pipelines can have a nice. It's nice for findability and searchability. And there's also a little preview of, like, the workflow graph. Unfortunately, they don't have cool looking metro maps because only Nextflow does that. But, like, you get an overview, you get some documentation, and you get that kind of quick export capability. So yeah, I think for people who are mainly on the side of consuming workflows, it makes things a lot more convenient potentially. So yeah, that's TRS in action.
And the findability piece is something that I think we could probably expand on. I mean, I think we're at this point we mostly write on NF Core, right? Like, if most of our users are in bioinformatics, so we can just send them to the NF Core pipelines page or whatever, and they can probably find the pipeline that whatever they're looking for. But if we're thinking more about the Nextflow community in general, we don't really have like a registry to search Nextflow pipelines. There is Doc4. People who happen to use it might throw their pipelines up there. But it would be nice to have maybe some sort of more comprehensive registry for Nextflow pipelines, and TRS could be one way that we sort of hook that into the existing ecosystem.
Yeah, definitely. Well, I mean, there is some thinking going on internally at Sakara about how we help kind of make Nextflow pipelines and related assets and modules and stuff like that too, just generally more findable and searchable. And of course, it's a fantastic resource. I've said it before, I'll say it again. It was one of the things that kind of convinced me to switch over to Nextflow, because I think it's a really cool community project. It's a fantastic example of grassroots engagement, but it's also from a very practical standpoint. It's a rich collection of pipelines that are community curated by people who are domain experts. Like that has a ton of value for the scientific community in general. Sorry, I get into cheerleader mode again, but it's really cool. However, I do think that as the Nextflow community expands, there will be more and more people who have their own pipelines who probably want to share them, but not necessarily through NF Core. NF Core comes with certain requirements, and there are certain rules. They all make sense, but for some people, they might either want to do their own thing, or they might be part of a local community in their domain that has already their project for that kind of thing, and that's okay. But I'd love to see kind of a federated ecosystem of projects that have these kinds of aggregations of cool pipelines and resources. Not everybody has to fit into the one mold, and so if you imagine, but then the downside of that is that if there's not one place to search for pipelines, you can end up not realizing that something exists that already covers your use case. So anyway, as a scientist, I would love to have access to something that's just one place where I can search. Imagine all the Nextflow pipelines in the world just in one nice interface.
Yeah.
There might be some people thinking about it, but that's for a future podcast, I would say.
Yeah, we'll see what happens. See what happens.
Yeah. Anyway, that's TRS. I guess we've got one more to talk about, which is DRS. DRS, which is the data registry or repository schema. We will put the definitive names in the description of in the summary of the podcast, along with URLs to all these resources and the things that we've mentioned. DRS. Do you want to give us a quick overview?
Yeah,
that one too.
Well, DRS is actually probably the one I know the least about, but fortunately, I think this is maybe the one that you've worked with the most. But what I can say about it is again, comparing it to TRS, it's kind of a similar concept, but for data instead of software. So it's this idea of having a uniform, like URL standard for accessing data across potentially many different sources. So again, you might have data across all these different repositories. I know that in life sciences, people like to have their little data platforms where you go to a website and pick out some data sets and you have a little cart and you check out, and like all these different little like groups like to do that for their own domain. And so having a single standard for accessing all the different kinds of data through uniform interface is super powerful, so that no matter how they're storing it, whether it's HTTP or FTP or S3 or whatever they're doing, you can have your client tool or platform or whatever can sort of access all of them the same way. Maybe you could speak to this more.
Yeah, absolutely. I mean, it's I've seen it in action. I've used it, and I've I've seen how helpful it can be. For example, back in the day, when the NCI, the National Cancer Institute in the U.S., was starting to move to the cloud, and this is, I will say, taking a step back, this is part of a series of efforts that are, I would say, more advanced in the U.S., but you're going to start seeing that more kind of across the world, I think, where certainly in the US, the federal agencies are very motivated to put large data sets on cloud. You also have research consortia that wants to put their data sets on cloud. It doesn't necessarily have to be cloud, by the way. It's just kind of, that's the main trend where that's moving. And the goal is to break down the traditional silos of access to data, because when you have data on that's on infrastructure where you have to have kind of a bespoke, dedicated way to access it, it really limits who can access it. And we're not talking about security, by the way, because when I'm talking about making data available, accessible on the cloud, it can be secured, it can be behind all sorts of controls of, like, do you have data use authorization, do you have the right authorization to access this data, and so on. So we're talking about ways these data sets are very secure. However, if you have the right authorization, it's not difficult to actually access it. That's the goal, right? So so there's been this move to create data platforms that enable that enable researchers kind of anywhere to access and work with data, just from the realization that a lot of money goes into those big efforts to collect large data sets, which are supposed to empower great innovation and breakthroughs and insights and all the good stuff, all the buzzwords. But that only works if you have a lot of people who are able to actually use it effectively, and that you don't have to jump through hoops for 6 months before you get to actually touch the data. Mm-hmm. And so data platforms get set up and so on. The original NCI cloud pilots started out with 3 groups that were funded to build data platforms separately. It was kind of not putting the eggs in one basket kind of situation. And they started hosting the data in cloud repositories. And the way you'd have to work with them is you're in the data platform, and you'd have a URI to where a particular BAM file or whatever piece of data lives, either on S3 or on Google, or wherever. So you have your URI for that piece of data, but it's something that is, at the time, it was specific to where that piece of data is located, like in a particular bucket, in the object store. And then they went through a phase of, oh, we need to move the data to a different bucket or structure it differently or whatever. And suddenly everybody's setup broke because everybody had these like GS path and S3 paths set up in their pipeline configurations or their sample sheets or whatever equivalent you're using, right? They move the data, and when you move the data, you get new bucket paths. It's not possible. It wasn't possible to use the old one for whatever reason. And so there were like months and months of difficult migration where a lot of people's work was interrupted and delayed, and it was kind of a big problem. Since then, they and many of later efforts who learned from those early fiascos, because it wasn't just that one, it happened in a few places, adopting DRS made it a lot easier, because then as a researcher, you go shopping for the data, but instead of a GS path, which is brittle, you'd get an actual identifier that can stay the same one for that piece of data and stays the same even if the data moves to a different platform. And so you can go to your nice interface and go shopping for data. You do an export to your platform. You basically generate the equivalent of a sample sheet. You have that. You can run your pipelines on it. If they have to move the data at any point, your configurations keep working because you're still accessing through the identifier. There's a service somewhere that makes the match between the identifier that you give it and the actual location of the data. And you don't have to care about that anymore. It's fantastic because if you think also about multi-cloud or hybrid setups, I don't want to have a different path for that piece of data depending on whether I'm accessing the one that's hosted on S3 or on Google or on Azure or on my institution's local system. I want to have just one identifier, and I want the platform to know that depending on where I'm calling from, if I'm calling from, I have my compute set up in Azure, it's going to give me the path to that where that piece of data lives in Azure storage for the large data sets that are stored in multiple places. And that's very powerful because that means that you can really streamline the process of accessing and analyzing data for the scientists, and you can kind of head off a lot of these infrastructure related problems that scientists shouldn't have to deal with. Anyway, that's my breathless pitch for DRS, which is when it was rolled out originally, there was some resistance. People are like, what are these URIs? Because suddenly in your sample sheet, instead of having the somewhat more familiar identifiers for your sample as the main thing that you needed to care about, and then having like a file path, which everybody understands, like even a GS path or an S3 path is still basically a file path in people's head, even though it's not an actual path on a file system. It's still relatable. But when you get a big old hash that's unreadable, that makes it's a cognitive leap that you have to make to understand that this ugly hash represents how you're going to access the data. Now, the data platforms have gotten better at hiding that stuff kind of behind the scenes as much as possible, and making it so that you don't. But in the beginning, you had to care about it more. But like as these efforts mature, there's more and more that gets pushed back behind the scenes so that people don't have to care about it. But if you understand the potential, it's like, oh, this is really cool, because it is really taking away all these potential stumbling blocks and obstacles to people actually using the data effectively.
Yeah, I mean, out of all of these standards, it seems to me like DRS has maybe had some of the widest impact in this space. Not so much in the Nextflow world. For some reason, Nextflow pipelines have never really used it that much, but I feel like the integration path is pretty clear here. I mean, because Nextflow already has this sort of nice interface to access many different types of storage. As you know, in a Nextflow pipeline, you can just throw in a S3 or GS or Azure URL, as long as you have the right authentication, and work with those file paths through the same interface. And so from Nextflow's perspective, DRS could just be another one of those protocols that is supported as a path. So, you know, you could throw in a DRS path, and again, providing the right credentials, and then you could work with them just the same, certainly for the purpose of just fetching data. That seems like very useful. But then also at the level of Sakara platform, there's an opportunity for even more sort of user friendliness, like what you were saying. Maybe then we can even hide the DRS IDs, where all these data platforms that already exist and have this like checkout mechanism, we just need to add a button to well, I'm not sure if they export to or if you import from them, but either way you do it, the ability to, you know, gather a bunch of data sets from some data portal and then import it into Sakara platform as a data set or data table, data sheet, whatever we end up calling it. We currently have the concept of data sets, but I think it needs to be expanded a little bit to support, you know, some more complex structures. But once all that stuff is in place, I could see that being very valuable, where you just being able to pull in data sources into the platform and then using it in your pipelines.
Yeah, exactly. And there's already some platforms that do this, and it's really convenient to be able to like literally go online shopping for your data. Some use an actual cart concept from shopping platforms. And yeah, the ones that I'm aware of, you go to the data registry or repository, and you do export to your platform of choice. You could imagine going the other way around too. I think it depends a little bit. But yeah, it makes it a lot easier. And also, I think the last point I want to make about that is that when you're using that, you're not actually retrieving the data from that data repository. So you're not moving anything around. You're just copying over metadata that describes what the data is and where it lives. So you import that into your platform, your computing platform of choice. And it's at the point where you launch your pipeline that the system will retrieve, oh, that this data lives over there, this data lives over there. But you're not copying anything, which means you're not paying for storage for that data sets, which is one of the main advantages as well for people kind of on the consumer side, is that you don't have to store massive like terabytes or petabytes of data. You can just point to it and then run on it and then move on with your research and not worry about that, which is great.
And the point you mentioned about a DRS ID being able to reference potentially the same file across multiple cloud platforms, I didn't actually realize that was part of it, but that is also very powerful.
Yeah, it's part of the vision. I don't know that there's an implementation that does it yet, but it is part of the vision to enable that.
Either way, I could see how that would be useful for. I mean, I'm thinking about all of this reference data that NF Core has that I think is all on AWS, like on S3 right now. I don't think it's currently being replicated on the other cloud platforms, but it's something that people want to do. And so then being able to just use the DRS ID instead of trying to keep track of whichever cloud provider you're using and maybe having like a map of different paths based on that would also just be a nice little convenience.
Yeah, it's just another thing that you don't have to worry about when you're trying to, call your variants or whatever your thing of choice is.
I don't know what you guys do. I'm a software engineer. I don't know anything about this stuff.
Well, I don't know anything about what you do, so we complement each other very well.
But like you said, that coming together between like the software people and the sciences people is like so important.
It is. It really is.
And I'm honestly surprised that we've gotten like as a technology space that we've gotten this far just doing that, like without having to become experts in both domains. I mean, some people do it. Some people just go and master both, and I mean they're impressive for doing that. But
yeah,
not everybody would have to do that.
Yeah, there's not enough people who can do that, and I think having the ideal situation kind of is when you have some hyper specialists who are absolutely the rock stars in their specific domain, and then you have a fabric of communication and people who kind of play at the interface. I'll advocate for that, because that's kind of where I live. Is kind of, I used to be a researcher, but I'm not an expert in any specific science anymore. I mean, I can talk to you about my PhD thesis all day, but nobody wants that. And I also, I'm not a software engineer, but I kind of understand how you folks talk mostly, and how the others talk, and we just kind of translate across the gaps. And I think when you have kind of a good composition with a mix of people, you can get to a point where it's very collaborative, and together we can really understand what are the problems that need to be solved, really, and what's the right solution, or the solution that's going to do the job. So
yeah, well, that's very much how I see these, this cloud workstream effort it is people coming together to figure that stuff out. And it is challenging, and this stuff does move very slowly. I mean, a lot of these APIs have been in development for years and years and years, right? It's not that they're lazy and they've been doing nothing, but there's genuinely like hard problems that have to be tackled.
Yeah. And it's a combination of like donated time and effort.
Yeah,
there's
too.
Some of the driver projects that donate staff time, and then there's just the fact that it's an effort that's trying to make a collaborative solution. So it's kind of the problem of deciding things by committee, that it takes a long time, and you have to find processes where, like, you can't make everybody happy, but how can you fairly get to solutions that satisfy the problem and that everybody can buy into? Not necessarily, it might not be my preferred solution, but it's a solution that I can live with and that allows me to do the work, and like thousands of people across the world can be happy with too. It's just hard, because also we're humans. But it's the only way that we make progress in a way that's inclusive globally, and that also kind of develops solutions that are going to be helpful to everyone, and not just like 3 groups that have the most fundings.
Right.
So,
well, Nextflow has come a long way by sort of developing, like by saying, like, we're going to develop these custom approaches that you take. If you stay within our box, our garden, then, things will work out well for you. But, these cloud workstream APIs they always sort of loom on the horizon. It's like, well, when the time is right, we can start adopting them. It'll make things all the easier. I mean, I will say that the main challenge, it seems like right now, is around authentication. So, how do you provide credentials to, one of these services that also gives it access to any underlying resources that you want it to use, underlying compute or storage resources, things like that. I think they're trying to sort of, all 4 of them are trying to align around the common, like a passport concept, like one sort of credential idea that gets you all the way around. And so again, it's a very hard problem. It moves very slowly, but once they do, come to a solution, I'm confident it'll be something that could be, very, very widely applicable.
Absolutely. Yeah, you mentioned passports. That's also a standard that's been in development for quite a while. Security is a hard problem, but it's there's some really interesting prospects there. So anybody who's interested in that, check out the GA4GH passports for sure. It's a really cool effort. And there's a new version coming out or has come out soon. Sorry, a slight aside there. It'll be in the descriptions. I think that's all we have for today. Ben, thank you so much for joining. This was a great conversation. I learned a lot, and I hope our listeners have as well.
Yeah, glad to help, and just want to shout out again. Well, first, I want to thank Venkat Malati over at Microsoft Azure and Liam Beckman over at Funnel. They've been helping, doing a lot of the testing with tests. And again, just want to call out anybody who wants to get involved in, helping strengthen these integrations. I can help you get started. I can sort of point you in the right direction if you want to contribute code or things like that. In terms of like the Nextflow plugin, any help is welcome.
Awesome. Well, you know what to do. Get in touch with Ben over Slack. And hopefully get a lot of DMs. That would be a great outcome, I would think. All right. Thank you so much. Thank you everyone for listening, and we'll see you and talk to you in 2 weeks. Bye.
Bye, everybody.